effect entities. And these effect entities are not so they're meant to be larger things, not individual signal components like these filters, time stretching or delay or resampling. So we might want to think about some class design as well. Yeah. Or we can go at it and refactor later. That's another thing. Yeah, but anyway, for now I'm going to implement this time stretch stuff because that's the fun part, and I need to do something fun. So we can just go ahead and delete a lot of stuff. We don't need these delay buffers anymore. We will need buffers actually, but yeah, we could keep this actually. I'm kind of torn. Yeah, let's keep it. We'll have to just make a convention for how we are doing the crossfading and which buffers are being used at any moment. Yeah, so it looks like this init code is fine. Yeah, and this is nice because it manages the vector. So the only thing we have to work on is here. This was just a delay line, so the reason why there is a vector here instead of just one buffer is because we don't copy anything. We just take a reference to this original buffer that's passed in. And this doesn't waste any memory because we're just tracking references which another object already owns. And instead of having one long buffer, we have many short ones. So for this class, we will probably need just a few buffers. And we could even create them. I think it's fair to say we can create them. Yeah. Yeah, I think that's what I want to do. Okay, well, let's just look at some code. So this is how they were, or I was, creating the filling up the buffers, just pushing them back. In this class, we don't need to really worry about that. So what we want, before we can start touching the actual audio, and that's here in odd buff, I believe in odd buff. Let's see. Buff is, what is odd buff? I'm not sure what odd buff is. Here. Yeah, that's just our pointer to the buffer, the actual memory part. Okay. So before we get there, now let's just assume we're already there. And looks like we're doing plus equals for some reason, and that's because there might already be stuff on there. Well, there is stuff on there. So this is an input-output thing. So we're given an input like this, and we output to something else, which is the stretched out version. So this one will look like, you know, something like that. It'll be twice as long if we are time stretching by a factor of 2. Yeah, so we're given this input in chunks, which are num frames long. And the reason this one was doing a plus equals is because that's a delay. It's a delay filter that adds onto itself for an echo effect. So this one doesn't need that. We will be able to compute everything by ourselves. Yeah, and it's an interleaved buffer, so that's why you have a +1 here. And yeah, this is the condition for when we should start writing to the buffer. So let's see. So now let's assume the sound started right here. Just ignore that first part. Oops. So what do we need to start writing that first sample? Well, we need just the first window. As long as we are... Yeah, that's right. Actually, this will need a long delay buffer now that I think about it. Right? Because the sound ends up being twice as long. So after here, there's no input coming in anymore. And we still have output. So, and this output corresponds to the middle. So we definitely will need at least... We will need a delay buffer of the size of the output. It can be a little shorter in actuality because once we move along, once we get to this point, right, we don't need anything before this. Yeah, so like I said, we need at least half. We don't need the full buffer, but we need half. And yeah, I think that's reasonable because we actually are delaying the buffer for that long. So in that case, we can do the same thing and just add a buffer like this. So that's nice because we don't have to change anything. We just track the buffers and push them back. Yeah, and then we can also have a cursor. So it looks like we used delay sample for the last one. In this one we can have a different... Yeah, we can have a different one called actually it can be delay sample, but it needs to be a float now because we are moving at some unspecified speed. And if we want that to be flexible, sometimes we're going to fall in between samples, and we want to be able to deal with that. So, I'm going to call it current sample. And should it be current sample? Yes, it should be current sample. And we also need... We have an int for... I take that back. We don't need to track which buffer is being used. Because once we... that is annoying. I was going to say once we finish it, once we finish with the buffer, so the buffers are another component that isn't drawn here, but buffers take up some unspecified size, like it could be 5, it could be 2.5 per green window. So they are independent of each other, essentially. And these green windows are probably what changes a little bit. But the buffers are set. So I was going to say once we finish one, we don't have to go back, but there are overlapping windows. Yeah, isn't that a little tricky? Yeah. I didn't finish drawing this picture, but in the resultant thing, you'd get something like this. So in the middle, in the last one, it overlapped at about the 1/2 mark. If you want to speed a stretch factor of 2, that'll happen at the quarter mark now. So here is where the buffer would overlap in the result. So here there's space loose and here there's space tighter pretty much. And then you get the stretching effect. Yeah. So with current sample, we're tracking this. That's not a good explanation. So these are our buffers that we have. Ah. And I do have to mention, these are real-time effects, and it's not possible to do time shrinking with real-time effects. It's only as possible as if you can predict the future. Right? I didn't think about that. But so this is definitely only time stretching. So, yeah, let's just go ahead and I think the simplest way to do it for now, we can expand on this later, is just to track where we are in each, within each overlapping window. So this is window A, and this is window B. And what I mean by that is at this sample, so this is the actual output sample. This sample corresponds to this item and nothing in B. Now at this sample here, this corresponds to the middle of A, or no, the quarter mark of A. This is aligned. And also the, I don't know, no, the 0th sample of the B window. I should probably use a straight line thing, but this makes more or less sense to me. Yeah, so if we just track these two components, we're okay. So for now, we're only using 2 overlapping ones. This will make a pretty crappy effect, but when you're doing it for, fun, sometimes those artifacts are not bad, like LPC and stuff. It sounds great when it sounds bad sometimes. So we'll have two windows. So that'll be window A sample. Unfortunately, that means we will need the index as well. I don't think we can get away with that. Yeah. We're going to need the index for sure. So that'll be a window A index. Yeah, and we might want to make this programmatic. I'm trying to think about that. Yes, that would be nice if it was programmatic. You know what? It doesn't have to be programmatic. I mean, we can do something like this, where we define the behavior of how many windows. It will be nice to have 3 windows or 4 windows in the future. So we can have, nah, screw it. I'm going to worry about that later, because that's going to trip us up. Okay, so we have window A and